Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Problem 86. The loss of head due to friction in an orifice, nozzle, or tube may be expressed as H sub L equals capital K, or loss coefficient, quantity velocity head, actual velocity head, where V is the actual velocity of the jet. For a tube with square edge or flash entrance, the coefficient of velocity is 0.81 and coefficient of contraction 1.0. Compute the value of K. Also compute the loss of head in millimeters if the curve edge tube or bell mouth tube with CISA-V 0.98, coefficient of contraction 1.00, discharges water under a head of 1.5 meters. So for part 1, K is quantity 1 over CISA-V square minus 1. So CISA-V is given, so K is 1 over 0.81 square minus 1. So K therefore is 0.5242. So that's why for square edge or flash entrance, K is usually taken 0.5. Then for the second part, head loss equals K times velocity head, actual velocity head. So the actual velocity head or the actual velocity is equal to CISA V times square root of 2GH. So squaring V square over V square equals CISA V square 2GH, or V square over 2G equals CISA V square H. And we substitute it into this formula. 1 over head loss equals 1 over CISA V square minus 1 times CISA V square H. That's why the head loss may also be, if we distribute, we have head loss minus CISA V square H, or head loss is head quantity 1 minus CISA V square. But we'll use this formula here. So head loss is 1 minus CISA V square H if we distribute CISA V square H into this quantity in this parenthesis. So substituting, head loss equals 1 minus 0.98 square times head 1.5. So the head loss is equal to 0.0594 meter, or 59.40 mm. 87. Water flows from a large tank through a 50 millimeter diameter orifice at the vertical side of the tank and discharges to the atmosphere. It is observed that the jet travels horizontally 2.1 meters while dropping zero point 0.4 meter from the contracted portion of the jet when the head in the orifice is 3 meters. If the diameter of the jet at the vena contracta is 40 mm, determine the following: the actual flow rate in liters per second, the coefficient of velocity, the power lost in watts. So for the solution, knowing the diameter at the vena contracta, we can solve C sub C, and knowing the coordinates of the point where the jet travels, we have horizontal distance 2.1 meter, which is taken x, and dropping zero point 0.4 meter, and we get from the relationship which I derive for the trajectory of the jet with axis horizontal, or the angle is 0 initially, or when the orifice is on the vertical side of the tank, so theta O is 0. So the relationship is x squared equals 4 c sub v square head times y. So from there you can solve c sub v. And since c is coefficient of discharge is c sub v, we can solve for c. And we use the formula Ka-Othog for the actual discharge. So for 5.1, Q equals Ka-Othog. And to solve for C, we need to solve C sub C and C sub V. So C is C sub C, C sub V. C sub C is area at the vena contracta over area of orifice. and pi over 4 diameter square over pi over 4 diameter square. So cancel pi over 4. So the diameter at the vena contracta is 40. So 40 square over diameter of orifice 50. So 50 square. So 0.64. Then from x square equals 4c sub v square head y. That's the equation of the trajectory of the jet when the orifice is on the vertical side of the tank, or the velocity of the jet initially is horizontal. So substituting, x is 2.1 and head is uh, 3 meters, y is zero point 0.4. So 2.1 square equals 4 c sub v square times 3 times zero point 0.4. From here we can solve c sub v. C sub v is 0.9585. Then C is equal to C sub C 0.64 times C sub V 0.9585. C is 0.61344. We then substitute into this formula here to solve for Q in liters per second. So we multiply the right side by 1000. So Q is 0.61344. C with area O is pi over 4.05 diameter square. Square root of 19.62 times 3 times 1000. 19.62 is 2G. So Q is equal to 9.241 liters per second. Then for 5.2, the coefficient of velocity, we already computed that. So 0.9585 C sub V. Then 5.3, the power lost in watts. So power lost is weight flow rate times head loss. And the head loss is head times quantity 1 minus C sub V square. So power loss equals weight flow rate Q times gamma water times head loss. And the head loss is 1 minus C sub V square times head. Substitute into this formula. So power loss equals 0.009241 cubic meter per second discharge. Area of specific weight of water 9,810 newtons per cubic meter, then head loss 1 minus 0.9585 square times 3. So the units would be in watts, newton meter per second, joules per second, or watts. So power loss is equal to 22.10 watts.